Welcome to 3D Flow Academy. This episode is focused on control points and control distances. These features are available in 3ds Zephyr Pro and 3ds Zephyr Aerial only. If you are a Zephyr Free or Zephyr Lite user, always remember that you can ask for a free Pro or Aerial trial by using the trial request form on 3dflow.net. Control points allows to define a specific coordinate in 3D space. That coordinate can then be used to calculate distances between other points and cameras, as well as constraint for alignment, workspace merge, and more. Since any reconstruction is up to an arbitrary scale factor, a translation, and a rotation, this tutorial will show how to define a global scale factor to perform measurements and align the work position, scale, and rotation with user-defined control points, as well as how to measure distances. More control points applications will be discussed in later tutorials. The easiest way to add a control point, yet the least accurate, is by picking it directly from the 3D reconstruction. Simply click Pick Control Point and click directly on the object. This function should be used only when you can deal just with 3D information, for example, laser scan point clouds. In this example, ground targets are available, so we'll use them in order to accurately pick the control points from images. Let's remove any previously added control points by right-clicking and selecting Remove All. From the Ground Control Points dock menu, click Pick from Images. The Control Point Picker window will appear. From the camera list, left-click a picture in order to view it in the Control Point Picker selector. Left-click where you want to place the control point and a red dot will appear. The OK button won't be clickable yet, as we need at least 2 images to define a control point in the 3D world. You can zoom in and out using the mouse wheel. Select a second image from the camera list. Note how cameras that see the point we just defined are highlighted. Once you have selected your second image, an epipolar line will be drawn on screen. The epipolar line will guide you in selecting the same coordinate on another image. Simply select the desired point by following the same procedure. The OK button will now be clickable. Note how the local and global reprojection errors in pixels are computed and shown in real time. Although the bare minimum is 2 photos for each control point, it's often a good idea to use a few more in order to be more robust to errors. Repeat this process for all the ground control points you need to define. You can rename control points using the right-click button and selecting Rename. Note how you can export control points as defined on images as a text file. This way, you can easily re-import the same control points without having to pick them again, in case you are reprocessing the dataset. In this specific example, we have the real-world 3D coordinates taken by a GPS on the ground control points, so we will use them in order to set the world scale and georeferencing. Using one control point, we'll translate the world. Using 2 control points, we'll translate the world and set a global scale. Using 3 or more control points, we'll set a full transformation that will scale, translate, and rotate the world. In this example, I'm importing the control points from a text file. Once the required control points have been added to the workspace, you'll be able to click the Scale Model with Control Points button. You can either import the constraints from files using the import function, or you can manually type them in. Note that each point can be selected as control, constraint, or even as both, by selecting the appropriate checkbox in the Constraint Control Point selector. You can either import the constraints from files using the import function, or you can manually type them in. It's usually a good idea to also include control points that are not constraints. Constraint means that the selected control point will be used to compute the actual transformation, while control means that the selected control point will simply be used to compute the residual error in the final transformation report. By default, the computed transformation will be a rigid one. Only a global scale, rotation, and translation will be applied to the reconstructed geometry, while camera's parameters will not be affected. You can also perform a bundle adjustment operation by checking Perform Bundle Adjustment. The bundle adjustment will adapt the camera parameters with the 3D control point constraints. You can adjust the weight of the control points over the type points computed automatically by the structure from motion algorithm using this slider. It's a good practice to avoid extreme values, even if you're very confident about your control points accuracy data. The bundle adjustment operation should be done immediately after the sparse point cloud has been generated. Otherwise, all other elements, dense clouds, mesh, texture mesh, will become invalid and thus deleted from the workspace. Besides georeferencing and scale, You can use control points constraint to guide the reconstruction towards a better solution. This implies that it is your own responsibility to select accurately control points and constraints. If you don't have any georeferencing goal and would rather use control points only to adjust the reconstruction, you can also use the Optimize Camera Parameters dialog from the Tools Workspace menu. With 3ds Zephyr, you can easily define control distances, which in turn can then be used to set a global scale. Control distances can be defined as the distance between two control points, the distance between a control point and a camera, or the distance between two cameras. Let's see how this helps. In this example, we have a few targets that we have printed in our scene. Although we do not know the relative or absolute positions, we have physically measured the distance between the target centers. Control distances can be defined via targets or by using known distances in the scene, for example, the width and height of an A4 paper. We can pick control points, or in this specific example, use the target automatic detection feature in Zephyr, and use them to scale the world with control distances. Define the desired control distances, then click on the Scale World with the Control Distances button. In the window that will appear, set the previously created control distances and set the desired distance value. Click OK and you're done. A residual value will also be shown. Once the world has been scaled, you can also use other tools available in Zephyr, for example, to measure mesh area or volume. Thank you for watching. Don't forget to join our 3D Flow Academy Facebook group to connect with us and to vote for the next video tutorial.